Welcome to another episode of Explained by AI. If you're just starting out as a Databricks engineer, you're probably seeing different ways to pull data into the platform. Today, we're doing a deep dive into two key ingestion patterns, Singleplex and Multiplex. Getting your head around these is pretty crucial. It really impacts how scalable and, maintainable your data pipelines will be. So let's break them down.
Yeah, absolutely. Think of ingestion as just getting that raw data from wherever it lives. Could be a database, files, an API, whatever,
Yeah.
right? And landing it safely in Databricks, you can start working with it. And the pattern you pick for that first step, it really echoes through your whole setup. We'll look at Singleplex, that's one dedicated pipeline per source, and Multiplex, where one pipeline cleverly juggles multiple sources.
Okay, Singleplex first. One pipeline, one data source. Sounds pretty straightforward. So like if I have maybe 5 SQL Server tables to ingest.
Exactly. With Singleplex, you'd build a separate, tailored ingestion job for each of those 5 tables. You're defining the connection, the schema, maybe some initial cleanup, all specific to that one table.
Right. The upside seems clear. Each pipe does one job.
Totally. If one source ingest breaks, it's contained, makes debugging, a bit easier. And if a source changes its structure, you just tweak its pipeline.
Yeah.
The others aren't affected.
I can already imagine the headache if you have loads of sources, like
Yeah.
dozens.
Oh, definitely. That's the big drawback. Maintenance just explodes. Imagine trying to update connection strings or apply a new logging standard across, say, 50 or 100 individual pipelines. It gets messy fast.
Yeah, a real zoo of pipeline.
Exactly. Scalability suffers in those larger setups, and keeping track of versions across all those separate bits of code or config, challenging.
So when does Singleplex make sense then? Is it ever the right call?
It does have its place. If you have genuinely few sources, maybe less than 20, it can work well. Also, if the sources are wildly different, like completely different formats or needing really unique processing that's hard to generalize, and for a quick proof of concept or an MVP where you just need something up fast for a small scope, Singleplex gets you there quicker initially.
Okay, got it. Small scale, very specific needs, or just starting out fast. Now, the flip side, multiplex ingestion, the Swiss Army knife approach, you said. One pipeline handling many sources. How does that work in practice?
So with Multiplex, you invest in building one more generic ingestion pipeline. The magic is that its behavior isn't hard-coded. It's driven by metadata. Think of metadata as like instruction sheets stored elsewhere, maybe a database table, maybe Delta files. This metadata tells the single pipeline, okay, for this source, go here, expect this format, use this schema, land it there. The pipeline reads that metadata and adapts on the fly.
I see. So you're not coding pipeline A, pipeline B, pipeline C. You're coding one pipeline and then just feeding it different instruction manual, essentially.
Precisely. You configure, you don't code for each new source.
That sounds like a massive win for environments with, loads of data sources coming in.
It really is. Scalability is the huge advantage. One robust pipeline can handle potentially hundreds, even thousands of sources. Maintenance is way more efficient. You update one pipeline, it affects all sources consistently, and adding a new source, often it's just adding a row to your metadata table. No new deployment usually.
Okay, that sounds much better for bigger, evolving data landscapes. What are the catches? There must be some trade-offs.
There are. The initial setup is definitely more complex. Building that metadata framework and the dynamic logic in the pipeline itself, that takes more upfront design and development effort.
Right, more thinking at the start.
Yeah. And debugging can sometimes be a bit trickier initially because an error might stem from the pipeline logic or the metadata for that specific source. You have 2 places to check. Also, if you hit a source that's just incredibly weird and doesn't fit your generic model at all, you might struggle or need to build a special exception handler.
So when should someone, like a junior engineer, really start pushing for a multiplex approach?
I'd say if you know you're going to have a decent number of sources, let's say over 20, or if you strongly anticipate significant growth, it's pretty much the standard for enterprise setups where you need that standardization and efficiency. Honestly, even if you start small but expect to grow, thinking multiplex from the beginning can save a ton of rework later.
You mentioned some specific techniques used in multiplexing, like metadata-driven stuff. Can you unpack those a bit more?
Sure. So metadata-driven ingestion is the core idea. You store source details, paths, file types like JSON or CSV, column mappings, validation rules centrally. Could be SQL Server, could be a Delta table itself. Then there's parameterization. Your pipeline, maybe it's a Databricks notebook or job, is designed to accept input parameters. The metadata for a specific source populates these parameters when the pipeline runs for that source.
So same code does different things based on input?
Exactly.
Yeah.
Dynamic notebooks are a common way to do this. One notebook, lots of different behaviors based on those parameters. And you also need to think about schema evolution. Good multiplex pipelines have ways to handle source data changes, like new columns appearing, without crashing.
Okay, that makes sense. Now, regardless of which pattern you pick, singleplex or multiplex, are there some general best practices everyone should follow for ingestion in Databricks?
Oh, absolutely. Foundational stuff.
Yeah.
First, use Delta Lake for your landing zone, your ingestion layer. Seriously, the ACD transactions for reliability, schema evolution handling, time travel, it's just built for this.
Yeah, Delta seems like a no-brainer there. What else?
Robust logging and monitoring. You need to know if your ingestion succeeded or failed and why. Centralize that reporting. Idempotency is key too. Make sure you can rerun an ingestion job. Maybe it failed halfway without messing up the data, like creating duplicates.
Yeah, rerunability. Crucial.
Yeah, definitely. And preserve the raw source data. Have a layer, some call it bron or just raw bronze, where the data lands exactly as it came from the source, untouched.
Like an archive.
Sort of, yeah.
Yeah.
It's your safety net, your audit trail. Allows reprocessing if needed. Also, partition your Delta tables sensibly, usually by date, maybe by source system ID too. Huge for query performance later.
Makes sense. Any tools within Databricks that help?
Autoloader is fantastic for file-based ingestion. It automatically detects new files arriving in cloud storage and processes them efficiently, left manual triggering. And embrace the fail-fast principle. If something's wrong, bad data, missing file, stop immediately. Don't let bad data sneak through. Clear error messages are vital.
Good point. Don't just silently fail, or worse, corrupt data downstream.
Right. Add retry mechanisms for transient issues, like a temporary network blip when talking to a source.
Yeah.
Makes your pipelines more resilient.
What about data quality itself and governance?
Essential. Build in data quality checks right at ingestion. Validate required fields, check formats, data types, catch issues early. If you're using metadata, manage its versions. You need to track changes to how sources are processed. And absolutely, think about security and governance from day one. Data lineage, where did this data come from? Audit logs, access controls, all critical.
Okay, lots of good practices there. To really make this concrete, can we walk through a couple more real-world examples? When would you definitively go one way or the other?
Sure. Let's say you're building a small internal app, maybe pulling data from just 5 specific tables in one SQL Server database. You can just write 5 simple, separate ingestion scripts or notebooks. Quick and easy. That's Singleplex.
Okay, simple case, simple solution.
Now, contrast that with a big company getting, say, 5,000 files dropped daily. These files come from 150 different partners. Some are JSON, some CSV, some XML. All need to land in Delta Lake. Trying to manage 150 separate pipelines. Forget it. You'd build one dynamic, metadata-driven pipeline. Classic multiplex.
Yeah, the scale dictates the pattern there. Any other examples?
Maybe you need to pull data from 20 external APIs. Each API has a totally different way of structuring its response, different authentication. Generalizing that might be more trouble than it's worth. So you might build 20 specific pipelines, one for each API. That leans back towards Singleplex, driven by the source heterogeneity.
Okay, that helps clarify the decision points. You also mentioned folder structures and metadata tables for multiplex. Can you paint a picture of what that looks like?
Yeah, a common pattern for the raw data might be something like bron at the top level in your data lake storage. Underneath that, you might organize by the source system name, like bron supporters or bron website clicks. And often, you'll partition by date for performance. So you end up with paths like bron supporters year 2024 month 4826. The actual data files like ordershunk1.csv sit in there.
Right, a structured landing zone.
Yeah.
And the metadata table.
Think of it like the control center. It'd have columns like source name, e.g. supporters, file type CSV, source path, bron supporters, targetable silver orders, maybe schema version, v2, to handle structure changes, and perhaps a last updated timestamp. So one row defines everything the generic pipeline needs to know to process supporters' CSV files correctly. Another row defines it for website clicks, JSON files, and so on.
Got it. That table becomes the brain guiding the single pipeline. So just to quickly summarize then, Singleplex is simpler for one-off sources, direct, but doesn't scale well in terms of management.
Correct. Easy start, potential future pain.
And Multiplex is built for scale, it's dynamic, efficient for managing many sources, but needs that bigger upfront investment in the framework and metadata.
That sums it up perfectly. More work initially, but pays off massively in larger or growing environments.
Any final piece of advice for junior engineers facing this choice on a new project?
I'd say try to think multiplex even if you start small. Design with flexibility in mind. Ask yourself, how would I handle 10 more sources like this?
Yeah.
Build towards that generic, metadata-driven approach if you can. It forces good habits. But, be pragmatic. If you have one truly bizarre source that just won't fit, fine. Make it a one-off singleplex exception. Don't force a square peg into a round hole. The goal is scalability and maintainability where possible. Understanding multiplexing principles is a really valuable skill to develop early on. It sets you up well.
Excellent. So we've covered the core ideas behind singleplex and multiplex ingestion in Databricks. Hopefully this gives you a solid foundation for designing effective pipelines. Remember, the right choice really depends on your specific situation, number of sources, how varied they are, and how much you expect things to grow. Thinking about these patterns early will definitely help you build systems that can evolve gracefully. Do you have any topic that you would like to have explained? Drop it in the comments.